The next important concept here is continuous AWGN channel into vector channel, that is continuous additive white Gaussian noise channel into vector channel. So we have discussed the concept of digital communication, which is represented by block diagram. Here we have message source, and this message source emits symbol. That symbol is converted to a vector of real number by vector transmitter, and then this modulator converts that vector of real number into finite duration energy signal. This signal which will be put on the channel so that it is available at the receiver. By the virtue of the channel property, additive white Gaussian noise will be added to the signal transmitted. Therefore, the received signal is not same as transmitted signal. It is now called corrupted signal. So from this corrupted signal, I have to obtain the vector value to estimate the symbol that is transmitted at the transmitter. So now we are in this section now here. So therefore, the part of digital block diagram is represented as shown here: transmitted signal and received signal and the channel with white Gaussian noise. So the received signal at the receiver here is given by x of t, which is nothing but the transmitted signal and the noise of the channel. So here we can define Si of t, that is transmitted signal, in terms of vector value and orthonormal basis function by this equation. Here, if we neglect the noise temporarily, x of t can be represented by this block diagram. What is x of t? X of t is applied to a bank of correlator which consists of orthonormal basis functions followed by integrator here. So this bank of correlator produces vector value for the signal that is received here. So now what will be the expression for this vector of real number, vector value xj, that is given by here integral 0 to t x of t phi j of t dt. That means here I have written incoming signal and I have multiplied incoming signal with the orthonormal basis function. So what is x of t here? X of t is nothing but the transmitted signal and the noise here. Substitute that equation here. So simplify Si of t into phi j of t dt plus integral w of t phi j of t into dt. What is this term represent? This term represent the vector value of the transmitted signal. What this represent? This represent the noise. So what is the expression for the vector that is produced here? That is the sum of transmitted signal vector and the noise. So we now going to show that continuous AWGN channel, which can be represented in terms of a vector channel like this. So this what we have to show. In order to show this, let us consider a stochastic process x dash of t with a random variable x dash of t that is given by the received signal minus summation j is equal to 1 to n xj phi j of t. So what is x of t? X of t is nothing but transmitted signal and the noise. What is xj? That is nothing but the vector that we have obtained here, it is sum of the vector transmitted and noise. Substitute here, simplify Si of t plus W of t minus summation j is equal to 1 to n Sij phi j of t minus j is equal to 1 to n Wj phi j of t. What is this Sij phi j of t represent? It represent Si of t. So this and this gets cancelled. Therefore, here a random variable that can be represented by noise only. W of t represent noise. Therefore, that equation shows the random variable of a stochastic process that depends only on noise process, that is W of t, and not on the signal. Therefore, let us consider x dash t is equal to W dash t, that is noise. So now you put x dash t is equal to W dash t here and get the expression for x of t. Bring this negative term to left hand side, it becomes positive. Therefore, I can write here x of t, that is received signal, in terms of a vector channel which is shown in equation 8, which can be represented here. That is, the received signal x of t is equal to the vector x1, x2, x3 up to n. There are n vectors followed by known orthonormal basis function plus noise. So this expression you are going to derive for conversion of continuous AWGN channel into a vector channel.